Good afternoon, students that are attending this Tech Talk. You're all welcome to participate in this Tech Talk. And our Tech Talk for today will be coming from Standard Bank, and we have our guests who are ready to talk to you guys about what happens Standard Bank, the opportunities that are there, how what you have learned here can be helpful to them. There will be a chat room which is available. If you have any questions, you can post your questions into the chat room. You'll also be given a chance to pose your questions after we're done with the presentations. So you'll be given the floor. So if you are to ask a question, you're supposed to raise your hand, and then you'll be given the floor to pose your questions. So let's take it on. Our first presenter will be Mabu from Standard Bank. He will be the one who will be presenting. Mabu, is all over to you.
Awesome. Thank you. I just want to time myself because I think I have some dense material that I need to get through. So I have until okay. I'm gonna share my screen, and yeah, as introduced, I'm Mabu. I'm a lead AI engineer at Standard Bank. And yeah, I'll talk a bit about what we do and what AI engineering is meant to be known to be. So let me share my screen. This one. Okay. Cool. So somebody can just ping me if you can see it.
We can see it, Mabu.
Okay, thank you so much. Cool. So today what I'm going to try to take you through, it's basically one of the things I've been recently passionate about, which is this argument that we should start transitioning to looking at AI capabilities as just tools, you know? So we went through a phase where AI was this complicated thing that needed PhDs and master's degrees and computer scientists to be working on it. But today, it's really just something that is usable out of the box. And I think that we need to start exploiting that, and especially like from an engineering perspective, whether you're a computer engineer or software engineer or whatever, we should really start thinking of AI as just something you can use as a tool. Like in biology, people are doing this already, because we know we have like advanced protein prediction models and stuff. So yeah, basically it's democratized now. And my argument is that we should start seeing a lot of it, and that basically requires that we start seeing it as just some tool that you can use, and without having to have the necessary mathematics and knowledge of deep neural nets and all of those things. Because yeah, it's kind of a black box now. I thought it would be appropriate for us to just start with understanding the concept of what data really is before we go into AI, because you can't do much of AI without data. But it's very important to understand what are you doing with data, because that also dictates what AI tools you can use. I hope that kind of makes sense. But the point is that, so you have this 4 categories of using data to do things. Né? Usually we start with what we call descriptive. If you've done like some basic data science, you'll think of this as like EDA and that kind of thing. But it's actually quite powerful. Most people don't use descriptive analytics sufficiently, because for the most part, a lot of business questions can be answered by just asking the question, what's happening? And almost all the time, you need to start with descriptive analytics to do anything. So for example, if you want to isolate where your fraud problem is at Standard Bank, for example, we need to see, are there any pockets of ATMs in certain areas that are actually, that we see fraud more than others? And then when that happens, it's descriptive analytics. So just trying to understand what is the problem, where the problem is happening. Then I'm not going to go through them one by one, but yeah, then you have diagnostic, which you can also use to, sort of start using data to diagnose what your problem is. You can think about diagnostic analytics in a factory, or even in Standard Bank, we use diagnostic analytics all the time. And then most people are familiar with predictive, which would be basically building models and statistical analytics tools to be able to predict, given what you know about your business or something. Given the data you have, can you predict the unknown or out of sample data points? And prescriptive is actually much more powerful, which then you can think about it the way LLMs work. You just take all the data you have, and then you understand, you expect the system to sort of try to say, these are the properties of your data, and for that reason, I think this is what you need to do. So yeah, much like LLMs. So feed it with a lot of data and then just start asking questions. And it will prescribe the solutions to your problem. Okay, cool. That was just some context on data. So let's talk about AI. I have a brief history of sort of where AI came from and how we got where we got today, and hopefully we can get through that quickly. So AI has a lot of definitions. I mean, there's so many people who I use AI to do this, AI this, AI that, but we sort of lost what is the meaning of AI by this time now. But in computer science, in the theory of computer science, AI is basically a field that studies the building of intelligent agents. And intelligent agents can be anything. So if you're doing robotics, you can be doing AI. If you're doing drone technologies, you could be doing AI with motion stabilization and other things. You can do rockets and you do AI when you build rockets and that kind of thing, because an agent is just an agent. Yeah, but anyway, the simplified version of it is just basically trying to replicate the cognitive abilities of the human brain. And yeah, that's about what the definition of AI basically is. But most people don't know this, but AI actually its inspiration came outside computer science completely. So it came from psychology. So this guy called Donald Hebb, he wrote this paper, this book actually, The Organization of Behavior. And then in the Organization of Behavior, he introduced what we call Hebbian learning. All machine learning models now, all deep learning models now that are doing backpropagation are using Hebbian learning. And Hebbian learning is basically the whole the idea that when you have a network, then you activate the ones that are likely relevant to the incoming query, for example. But it's just like now you have networks that will turn on together and others that will switch off together and that kind of thing. But basically, that's all that neural networks and deep learning models are doing today. Because yeah, there hasn't been a very useful alternative to backpropagation. We don't like it technically because of its limitations, but it works. And it's coming from psychology with this book, The Organization of Behavior. And obviously, Alan Turing, came with the Turing test in his paper in 1952, Computing Machinery and Intelligence, and popularized the idea of an intelligent agent, which would be basically what properties should a computer have for us to consider it intelligent. I mean, the Turing test is not the best to test a computer's intelligence, but it's what we have today. And then arguably one of the first person to ever build a neural network, basically build an intelligent agent using all the stuff that we just described now, is Frank Rosenblatt. And then he built what he called the perceptron. It was literally a physical device that used all the ideas of Hebbian learning and what Alan Turing described with Turing computers to try to predict whether something is a triangle or it's a circle. So actually the first neural network was a convolutional neural network, but it was mechanical. So, and then we know exactly how neural networks are modeled in mathematics. So basically the idea is brain inspired, but I mean, they're nothing close to what the brain is doing, right? We're not compute backpropagating gradients in our brains when we think, but we have some inspiration from some neurons. But it's very simple. If you take a single layer perceptron, it's basically a function that will sum weights and data and then return the results. That's all that it does, and compute some kind of activation function. This architecture has a lot of problems, and this guy called Marvin Minsky wrote this book in some few years ago after people got sort of interested and excited by the idea of doing AI. So he just demonstrated the mathematical limitations of the perceptron. But what Minsky didn't get right was that he was thinking about the single layer perceptron. But later, after we had GPUs and stuff like that, then we had like deep neural nets, which is multiple layers of perceptrons. And if you have multiple layers of perceptrons, then they don't have the same problems. They don't have the same problems that a single layer perceptron has. But some of them still do. I mean, for example, we know catastrophic forgetting. Catastrophic forgetting, basically, it's if you take a neural network and train it how to recognize that something is a cup, and then try to take the same neural network to make it how to recognize that something is a cat, it forgets how to recognize cups. And then so this is what we call catastrophic forgetting. And it's in the nature of the weight adjustment inside those functions. We also know that even big neural networks today suffer from what we call adversarial examples. So you can adversarially attack a neural network into classifying something into something. So if you think about, using face recognition to open a door, I can actually adversarially attack that neural network to think of me as the CEO of the building or of the company, and then allow me to get into places I shouldn't be getting into. This is actually quite a big problem. There was a paper that came out from MIT where Professor Donsong demonstrated that you can adversarially attack a Tesla into thinking that a stop sign is a 20 miles per hour speed limit, and it would never stop. So yeah, these are very, very big problems. We know even with LLMs now, you can adversarially attack them to say things that they shouldn't be saying. And so far, we are working on what we call artificial narrow intelligence, but everybody is talking about AGI. I'm sure you've heard it everywhere now. People, AGI this, AGI that. But AGI, yeah, and we don't have it anywhere currently, because most of our neural nets, all of them, what they do is that they you have a self-driving neural net, you have a chatbot neural net, you have a music generation neural net, but they're not multimodal. People are working on multimodalities, but also multimodalities is not a sign of AGI. AGI basically is that we want to build a neural network that is as smart as a person. That's all. Like in terms of take new data modalities, new environments, everything, it should be able to learn on the go, and then have some kind of like knowledge of physics that we sort of come baked in with. Like, for example, if I jump, I'm gonna come down because there's something called gravity. Usually we actually don't even teach kids certain things. They just learn them out of the bootstrapping of their DNA. So we want to build a neural net that can be as clever as a kid. And then we have something called artificial superintelligence. This is where, Ray Kurzweil talks about the singularity. The idea is that one day we're going to have a machine that is so intelligent that it will be intelligent than all humans combined. So now we have a super intelligence, and we have to report to it now instead of computers reporting to us. I'm going to rush through this, but just to demystify this. So if you think about it, artificial intelligence is a field of study. You guys, are in university, you know exactly what fields of study are. And then under that, you have something called machine learning, which is the use of statistical approximations. And then under that, you have something called deep learning, which is now you're using mathematical approximations, but you're stacking them on top of each other. So that's the difference. And yeah, AI can do a lot of things, but I'm going to skip through this quickly. And this is deep learning. So you'll see a simple neural net will be a single layer perceptron where you have this thing on the left, we'll call it one layer neural net. So we don't count the input and output layers. So it'll be one layer neural net. And then on your right, you'll have a 4-layer neural net. So this is basically what makes a distinction between deep and simple neural network. And the reason why deep learning took off, because there's a lot of people who say, no, we can just do this with statistics. This is just fancy statistics. This is just that. But we demonstrated that that's not true. Like, this is actually something different. And the reason, for the most part, is that deep learning, when you increase data, you get better performance. That's very unlike statistical models. In statistical models, you reach a point where it doesn't matter how much data you get. You cannot get any improvement. But with deep learning, we can demonstrate that if you increase your data by X, you get X amount of performance in return. And that's why it works. Okay, cool. So I'm going to describe some of the deployment stacks that we use at Standard Bank. And just sort of now that we know all about this deep learning, how do we commercialize it? How do we make it work? And we use it for many things. So yeah, this is part of what we call DMM, which is digital money management, that we use machine learning to sort of help customers understand with things like budget, and money forecasts and all of those kind of things. And then we use a lot of deep learning in that. But before we go into that, I want to describe this. So recently, what we have realized is that actually machine learning and AI in general, it's no longer a science problem. It's an engineering problem. So it's a computer science problem. It's not a it's not hypothetical in a sense of what can we do to get better results? What can we do to do what? It's actually like, how can we make it work in production? That's more painful. So because the reason for that is that the machine learning code that you write, which is the model, the neural net that's going to make predictions, it's like close to 1% of the entire stack. And the entire stack has nothing to do with machine learning. And it doesn't require a statistician to work. It's like hypervirtualization, distribution of GPUs. So these things are very, very complicated. They're more complicated than writing that machine learning code. And typically, data scientists will go to a Jupyter notebook, write some fancy statistics, and then say, I have a model here. We can serialize it as JSON or something. And then you can use, joblib to load that model and then do the predict. It doesn't work that way. Okay. So because of this is why the idea of AI engineering is becoming popularized, which is basically a full stack engineer who can build models, who understand statistics, but who also understand computer science. Like, how do I make an API fast? How do I, should I do a get or a post? How do I do memory virtualization? All of those things that were sort of useless to machine learning are becoming very, very important to do it in production. You can't do it in production if you don't get these things right. And to summarize how AI in production works, and typically we call it applied AI. This is how it works. So basically, usually it starts here with the business analysis. So with business analysis, business will say, I want to predict the budget of my customer, and then we analyze, first of all, why, and all of those things. But those are business decisions, but it's part of the workflow. If you don't get the BA right, the business analysis right, your whole workflow is not going to work okay. Because if you don't get the business analysis right, your data engineering is going to fail. But typically, the second step becomes data engineering, where we say, okay, cool, what data do we need? What data do we have? Sometimes data engineers actually inspire business analysts. So this is why this is a circle, because you could start with data to define a business problem, but typically what you want to do is start with a business problem to dictate what data you need. Then obviously it's modeling, everyone's favorite. I want to build a model here. And modeling is complicated. Most people think it's just, in sklearn it's very simple, right? It's just .predict, .train, and .feed, .predict. But that's not how modeling works. Usually it involves a lot of feature engineering, which is not very nice. And people would sort of ask data engineers to do the feature engineering for them. But typically we don't want that. And then you have deployment now. So should I make this a fast API? Should I make this Spring Boot and use Java to do inference with the model that I just built? Should I do this? Should I do that? What is the workload of the API given how many requests or how many users I have and all of those things? And those will lead you into infrastructure decisions. So infrastructure decisions would be, do we distribute CPUs or do we just punch this thing into one GPU? If we do that, what is the cost? What is the limitation? What is this? What is that? So that's infrastructure. So typically what we expect from an AI engineer is that they should have high quality conversation across all the stages. And you'll see, so for example, this is one of a deployment pipeline that we use at Standard Bank to power a feature on the mobile app. The way it works is that it'll consume data from a SQL database and then consume data from Hive tables. So, and also that's always the problem that pops out is that you have multiple, so we are very old as a bank, so we have data sitting everywhere. So just to get data somewhere, you need to consume like 10, 15, 100 different data sources. And data scientists don't like that. They want it to be in one place, but you would not find it in one place. We use PySpark a lot because obviously we want distributed computers because we have a lot of customers, we have a lot of data. So I mean, one of our expense table or something is like 10 billion records or something. And then all of those records must be processed. So we use PySpark to do processing, to do training, to do inference. And then this is what we call an offline inference architecture, where you basically do batch inference and then write to a database. Then this analytics database here, it's a giant Postgres cluster that will be consumed by a Spring Boot API. So Spring Boot is Java. Java will consume this database and then surface the request in real time to the customer on the mobile app. So it's complicated to get this right, as I indicated initially. And yeah, there's a lot of complexity beyond just the machine learning model. This is what we call a cloud native deployment. So this was, so the use case here is that we wanted to, so we get a bunch of calls, like customers call us, and we actually typically we don't know what did the customer say, like, except for the agent who was helping the customer. So what we want to do is that we want to scale the processing of all those call recordings so that we can start making some meaningful business decisions out of it. So we made it a cloud native deployment. You see here, you have this AWS Connect technology, which allows people to, to do call center stuff. And then you have an S3 bucket that stores all the recordings. And then our sort of AI deployment starts here, where we have a SageMaker data wrangler pipeline that has to consume the recordings and put them somewhere, and then we have Lambda triggers that have to trigger that thing in event-based triggers. We have like AWS Athena here, which is basically a SQL interface to S3 buckets. And every single time a recording lands in this bucket, we trigger a transcription pipeline, which we use AWS Transcribe to basically transcribe that call. And then after transcribing the call, it's going to put it in another S3 bucket, which will trigger another pipeline that will start doing transcription processing. And that will include the inference pipeline, which is now saying we want to thematically identify the call and then use machine learning, deep learning. We spin up some GPUs inside this inference pipeline. And then we use deep learning, open source deep learning models, by the way. And then we write what we call a voice of client database data set, and that can be consumed across the bank. Somebody could ask, in insurance, I want to know how many calls I got last month that were asking if they can change their claim or something. And then you get hybrid deployments. So this is every company right now has what we call a cloud migration strategy, because everybody is going to the cloud, and like decommissioning on-prem infrastructure and all of that kind of thing. But when you have that situation, you need to combine the two. You need to combine what's happening on-prem with what's happening in the cloud, and that almost always involves a data transfer a layer. So this is the deployment. The infrastructure we deployed for one of our projects as well, where we consume Hive tables on-prem and that reservoir things that I was showing you, but then we use data sync to push it to the cloud. And then once it lands in the cloud, it triggers some pipelines. And it was just Elastic MapReduce. Elastic MapReduce is like serverless Spark. So it's a serverless Spark architect infrastructure. And then we use that to do our Spark magic, and then we persist into an RDS database, which is the Postgres database thing. It's still offline. It's still an offline inference mode because you're doing batches, but it's completely in the cloud, except you're just consuming the data from on-prem. Okay, so what I've described, I'm sure you're wondering, what can I do to know these things? How can I work in a team that does something like this, right? So typically we follow this model. So like I said, identified components of the deployment infrastructure, right? I mean, of the AI workflow. So you have data engineering, modeling, the deployment, business analysis, and infrastructure. So we identify these roles by saying, at what component are you skilled up? And my argument, you can see this, the machine learning engineer will be good at data engineering, good at writing models, and good at writing APIs for deployments, right? But my argument is that because our brains don't get full, you don't get like storage full in your brain. So what we typically try to model people to do is to be good at all of these things. So like I said, we want to have a high quality conversation with you about AI infrastructure, because it could have costly implications if you don't have high quality conversations. So you need to be skilled up for that. Business analysis, everybody needs to be good at business analysis, because that's like literally understanding what the problem is. So if you do not know how to do requirements analysis, you are likely going to misdiagnose what your problem is and what software to write. Deployment is something tricky. People don't like it, but you have to skill up for deployment, because your model won't work if it's not deployed. There was some crazy statistic from Gartner or something saying 80% of models don't go to production. That's because there's no deployment engineers, and the people who are building models do not have deployment capacity. So you need to skill up for that. And modeling and data engineering is obviously like you have to know these things. I'm running out of time, but yeah, this is basically showing you, this is a report by Workera that I can share later with you guys. But this is basically showing you what skills and what competencies are required, and what packages, tools you need to know for you to be a good machine learning engineer or data scientist across that stack. Cool. So now let's look at AI as a tool, right? And I hope I can cover this. Okay, I still have some 5 minutes. So the argument that I'm going to make here is exactly what I said when we began. AI is no longer a research problem, okay? It's a software problem. So the way you want to think about it is that if Google releases a model in TensorFlow and blah, 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 for you to use it in your development workflow and what, you don't need to know how Google built that model. You don't need to know the TPUs that built that model that Google released. You just need to know how the model works. And once you know how the model works, you can solve all kinds of problems with models by abstracting the research difficulties of that away from your workflow and just saying, I'm going to take this model. I know these weights are going to work like this, and then I'm going to use them in my thingy. I mean, that's the way we sort of scale up the usage of AI into applications, right? But there are times where instead of just using a model that Facebook released or something, you want to train yours, and that's a different situation altogether. But once you have a model, the argument here is that there's no reason why you don't have AI on your website that you're building. There's no reason why your mobile app is not using AI, just because you don't have research engineers, AI researchers in your company. Pip install transformers. This is one of my favorite open source package out there. So transformers will basically, they have this model zoo where all companies, when they release models, they put them there. Then they build this thing called transformers to be able to use that model and to fine tune the models as well, to fine tune them on your downstream tasks or on your data. Very simple. Pip install, and then you're done. One of the most friendly libraries out there. Pip install supervision. Supervision is the leading image recognition, basically image processing package out there. So you can imagine analyzing this is actually nice. They are in real time analyzing like people walking in the airport. So like to do it, this is the code, you see. So it's not complicated at all, but it's very powerful what you can do with these things. Model APIs. Typically when we build low volume, high latency, like low latency APIs, we experiment with things like fast API in Python or Flask, but they typically don't scale up to the like 11 million requests per hour type of AI requirements. And that's when you start considering Spring Boot and other things. Typically, you'll be forced to do offline inference because of those API limitations. Because online inference is typically easier in Python than in Java and other languages. But in today's world, you can do machine learning and deep learning in every language, including JavaScript. Right? You have like fancy things like this where you can start using like things like LLMs with pandas and then asking questions about your data. So for example, you're literally talking to it. So you have data and then you just want to know, how many of my customers bought what, and then you in natural language, but in the background, there is a bunch of machine learning. But this is just tools that you can have. LLMs, everybody talks about LLMs now. So yeah, I mean, I don't know how many people actually know how painful it is to train an LLM model, but is it useful to know for you to use it in your application to use ChatGPT? I don't think so. And it must be reserved for certain people to know those things, but you cannot argue that you cannot integrate ChatGPT like capability in your application because you are not an LLM engineer. That's the excuse. There is a new concept called offline models, where instead of calling APIs, the model actually runs locally and natively. So it includes things like quantization and ensuring that models are small enough. I mean, Microsoft is very passionate about what we call SLMs. SLMs are small language models. People usually talk about LLMs, which is large language models, but SLMs are a new trend that's coming out. I mean, Microsoft released their Pi3 model. And then when you compare the Pi3 model, which is an SLM with like 3.5 billion parameters, comparing it to Llama 3, for example, which comes from Facebook, that SLM can outperform Llama 3 on certain tasks. And this is where offline inference is going. So you literally, when you install our mobile app in the future, it will also come with a piece of a .bin file, which is an actual LLM that's going to run on your phone. And there's no API calls, and that allows us to do privacy preserving things. Yeah, and also this idea that when I work with people all the time, they have problems demonstrating models, right? You're out there showing an executive a Jupyter notebook. They don't want to see that. They want you to build a very nice interface, show that the model can do this, can do that on a thingy, and then people get the concept instantly, and they can even get inspired to improve on all of those things. So the tools are there, few lines of codes, and I mean, I think in 2024, somebody said jokingly that the most popular programming language was English. And the idea is that we use English these days just to write code. It's not code bases are going from 1 million lines of code to just something like 1,000. So it's never been less intimidating to be a programmer and write code that is powerful and then can be able to be operationalized and commercialized. Okay, cool. So I think I marathoned through that, but I'm sorry I didn't have enough time. But I hope you found this useful. But yeah, Prof, I'll hand over to you.
Thank you, Mabu, for a very informative, inspiring presentation. I guess the students really engaged with your presentation, and they will have some questions they will ask once we get to the question and answer session. So students, please make sure that you have some questions that you're going to ask Mabu. Mabu will be here to answer your questions that you may have. And now we're moving on to the next section of our tech talk. So we're going to have Venessa, who is going to speak to us now. Venessa is the program manager, youth development and employment at Standard Bank. So she's going to share with us the youth offerings that Standard Bank does have. It's over to you, Venessa. Venessa, it's over to you. You may be muted. Venessa, you're muted. Sneh, will you be able to assist with unmuting Venessa? I don't know whether you...
Thank you so much. Sorry, I couldn't unmute because the host needed to unmute me. I just want to share my presentation quickly, and while I'm doing that, we just want to, Sneh, could you perhaps allow me to share my screen? It's saying it's disabled. Okay, while Sneh is trying to help me or give me permission to share my screen, my name is...
Can you share now, Venessa?
Oh, thank you so much, Sneh. Thank you. Are you able to see my screen?
Yes.
Lovely. All right, my name is Venessa Oger, and I'm with Standard Bank Youth Development and Employment. It's certainly a pleasure to be speaking to all of you today. And, I chatted to Lena, and she said there's quite a big population of students. What I want to do today is do a positioning of what our youth offerings are at Standard Bank. And I've been with the bank for 10 years. It's been 10 scintillating years. I get to work with people like Pooja and Mabu. So it keeps me, on my toes. And I think my passion is dealing with the youth. And when I look at that high unemployment youth that we're sitting at, it's over 6.3 million, youth that are unemployed. What we need more and more of is catalysts within different organizations to create youth offerings to offer to students, just to bring down that scary stat. So it is my passion. I've been chatting to youth for in excess of 15 years, so it's a long time. Right, so when we look at the Okay, my slides don't want to move, so I'm gonna carry on speaking. So when we look at youth at Standard Bank, it's a strategic pillar, because what we believe at Standard Bank is that we need youth to come in. You come in with untainted ideas, you have the ability to bring new thinking, and Standard Bank is more than 160 years old. And in order for us to keep Standard Bank going, to keep it relevant, we need to ensure that we bring new blood into the organization to get those new ideas infused, and we will be around for another 160 plus years. When we look at the youth programs, we very intentionally looked at how we can actually create very bespoke offerings. And we hire, graduates for our graduate programs permanently. And then we have what you call internships and learnerships. And there we're looking at more, at youth at mass. And we have fixed term contracts where we would, do various offerings for those two offerings as well. So with the graduate programs, we are very deliberate about what we do. So what we do year on year is we have discussions with business. We look at their strategy for the next 2 years. We look at what capability pipelines, we need to build, and we align the graduate programs to that specific capability build. Now, you heard from Mabu and you heard about AI. What is come, fast and furiously to the fore is a need to have graduates that have science, technology, engineering, and maths. It is imperative for any organization, whether you're looking at the local context, of technology, or you're looking at it more globally. We would need to, hire grads in the STEM disciplines. And what we do, year on year, we look at our future transformation journey. Because if we look at where we came from when we had COVID, what we thought would take us 10 years to build from a digital transformation perspective, we actually managed to bring it down to 2 years. So we have quite a number of programs that are looking for STEM disciplines. And one of the signature programs that we have at Standard Bank that is leading in the market, and we were one of the first banks to actually build this capability of data scientists. So we had a Pan-African program in 2017, and so we I was on that journey from the time we brought the data science program up from ground zero, and we then launched it Pan-African, and now we also have one that we have in South Africa. And what we do is we also bring various candidates or graduates and permanent staff onto the program from all the different geographies around the continent. And the program, if you look at it, we are leading in the market. And we've also built out what we call behavioral economics, because we believe there's a massive interplay with behavioral economics and data science. So those two programs are at the forefront. We look at graduates that are studying STEM disciplines. You're hired in a permanent capacity. We put you on a mastery program. So for data science, we're hiring engineers, and you're going to hear from Pooja just now, because Pooja is from UKZN, so it's an alumni. And she's going to explain to you what her journey has been, and how you need to actually think broader than looking at your career in a very linear fashion. Because what we say, irrespective of what youth offering we have, is that we hire you for your ability to think. And what we want is people that would be able to look at problems, but look at it from the left field. We're not looking for, the stock standard thinking. And that's what's going to elevate a Standard Bank as an organization in a global context. So data science is one of the programs that I would urge you to apply for. And, it's a culmination of your business acumen, so your business skill, your maths, your stats, and we're looking for that intersection where that intersects. And we're looking to grow that program. So what you would do is you would join on a 12-month program. You would go into a very high intense training program for data science. And it spans over 12 months. You would go on different rotations. And right towards the end, we have the different heads of businesses come into the room, and we then place you into a particular business unit. So that's one of the programs I wanted to elevate. On the technology side, we have in excess of, I'm going to say 15 programs, and it spans from your machine learning, your machine learning to AI, to data engineering. So there's a whole array of programs that you can apply to. The technology programs, you are hired in a permanent capacity, like our other grad programs. You also have a very bespoke learning pathway for the duration of the program, and it spans from 12 to 18 months. From technology, we're also looking at the commerce side. Now, you're going to hear from Pooja. At Standard Bank, what we believe is, and I'm going to give you a very laymanized example, we have engineers sitting in finance. And we did that for process optimization because engineers, when they look at a problem, they can optimize processes. So we've placed them in finance and they work in finance. We have data scientists in our coverage areas around the country. So it's a very varied approach that we use. And when we look at cognitive ability, we believe that if you have that cognitive potential, you would be able to apply yourselves in the context of the business and add value. And so looking at the commerce side, we also have in excess of 20 programs, and that spans over, economics, technology, there's psychology, neuroscience. So it's quite diverse when we, look at our youth offerings at Standard Bank. So what I want you to do is, for the graduate programs, majority of our programs, we're looking at an honors upwards. There are some programs that we're considering undergrads. So what you would need to do is get onto our website, and you would need to look at all the minimum requirements for the 40 plus programs that we have for graduates. And you would need to match suitability according to what your interest is. And you would need to apply with your resume. You would need your full academic transcripts. Now, I think there's also a myth surrounding, when we look at aggregates, the question that I get from thousands of grads when we do our talks is, Venessa, do you only look at A aggregates? And on the contrary, we're looking at an aggregate of 60 plus for all our programs. So, and obviously, if we're looking at it in the context of the program, and if it's behavioral economics, we look at what you've got for, your economics module. If it's psychology, we look at the psychology as a major, what you're getting for your psychology module throughout your studies. Now, I also want to demystify another myth, because I think, when you think about corporate, I'm going to speak in the context of Standard Bank, though, you think that we are, we look at just your honors results. But if you were floundering, say in your second year or your third year, and you came down in a few modules, what we do is when we're looking at CVs, we look at how you actually bounce back. So even though you didn't have a good year, and if you rebound higher the following year, you're still in the running. So I just want to make sure that you understand that, because I think you put immense pressure on yourself and you think that there's a perfect fit or a perfect mold that we're looking for. And on the contrary, when we see students that, didn't do so good in the second year and you rebound higher, it speaks to that, element of resilience, perseverance. So we're also looking on the softer side, when it comes to skills, not just the technical side. So all the grad programs applications have opened. I think there's just about 3 in my portfolio that will open maybe next week, but all the programs are open. If you Google Standard Bank graduate programs, you get onto the early careers website, and all the programs are advertised there. You need to understand, when you're submitting your application, it is compulsory for you to submit your ID, your CV, and your full academic transcript. So just make sure that you have that on hand. And then your application comes through. You're going to be going through, a psychometric assessment right at the beginning. And if you're successful there, you would progress to the different stages of the process. So that's the graduate programs. We then have your learnerships. We take in excess of 800 to 1,000 learners every year. That's a fixed term contract. It spans across technology, your STEM disciplines, and commerce. And I would urge you to look at that and use it as a backup if you don't get onto a graduate program. Then we have internships. Now, here we don't have in-person internships just yet. We decided to be adventurous, so we have virtual internships. And if you Google Standard Bank virtual internships, you would also be able to complete a virtual internship. It takes you 4 to 6 hours, and it's self-paced, and you can complete that. What it does when you complete it, it gives you a certificate, and you can, put that on your portfolio or on your CV, and that weights your CV. So I know I don't have a lot of time. So what I want you to do is apply before the 30th of June, because all our graduate programs close on the 30th of June. And in the context of learnerships and internships, you would need to keep your eyes peeled to see, because we have iterations throughout the year. So I want to wish you all the best for your applications. We get in excess of 38,000 applications a year. So you would need to differentiate your CV. So I'm going to stop there. I can see Prof is online. Prof, I'm going to hand back over to you.
Thank you very much, Venessa. I think the students have had their opportunities at Standard Bank, and you don't have to get the A marks for them to consider you. So just consider Standard Bank when you're thinking of your future career prospects. Thank you very much, Venessa, for that. Now we're moving on to the last presenter for the day. It's Pooja. If you have heard, Pooja is a UKZN alumna. She will be sharing her experience of transitioning from being a student into entering into the work world. Pooja, the floor is yours.
Sure, thank you so much, Prof. Okay. Hi, everyone. I'm Pooja Philip. I am formerly from Durban, and I was a UKZN student through my undergraduate as well as my postgraduate studies. So I've always been very passionate about science. I completed my BSc and my honors in chemistry, and then I went on to do my master's in chem as well, where I specialized in material science and photocatalysis. So, spending so many years as a student definitely made me a bit anxious about transitioning into a professional environment. And that's where the grad program came in. It was the perfect intermediary or stepping stone that provided me with all the skills and experience that one would need to start their careers. So our training was threefold. We had rigorous technical training, which was highly beneficial to me as someone going from a chemistry background and being in the lab all the time into data science. They started us off from scratch with the different tools and techniques that one would need as a data scientist, like Python, stats, cloud computing, advanced machine learning, and even data engineering tools. There was also professional development classes, in communication, leadership, and other soft skills that you would need to thrive in your career. And lastly, we had personal coaching sessions on a monthly basis, which dealt with a lot of self introspection to help you stay focused and motivated during the course of the program, as well as equipping you with the tools you would need to overcome obstacles and build your overall sense of well being. Also included in the program, and something that was a massive help to me, were 3 month rotations within different business units in the bank, which gave us the opportunity to learn about these different areas and gain hands on experience with projects. This also helped me gain a holistic understanding of how the organization operates as a whole. And then something that was a bit of a challenge for me at first was having to move to a different city for the first time. And my managers were so completely supportive and always checking in on how I was adjusting to the change. We also assigned buddies, which are previous grads, to support us through the program. And my buddy was someone that had moved from the Western Cape. So she gave me advice on how to navigate through it. So it was so thoughtful to have a buddy assigned to you that had a shared experience to you. Apart from the overall cohort of graduates that eventually become your closest friends that you can always lean on for support. And then in terms of highlights, we have regular connect sessions, which really helped me network and get out of my shell. But for one particular connect session, we got to meet our CEO, Sim Shabalala. And what really stood out to me was that he made an effort to meet with and engage with every single one of the grads in that session, which actually speaks to the overall culture within Standard Bank itself. Our senior leadership are always approachable and accessible, which makes you feel comfortable to reach out. I've also worked on some really cool projects during the course of last year, participated in hackathons, and at the moment, we're currently building NLP models to allow us to automate a lot of our processes. And it's been really interesting, and it's made me so passionate about the field of data science. Um, I can say that after the program, I've grown so much, both personally and professionally, and I've gained a deeper understanding of my strengths. And I think I've come out the other side a more confident, well rounded, and adaptable individual. So, overall, such an amazing program that essentially serves as a catalyst for growth and allows you to learn so much while still gaining that hands on experience, so that you have a solid foundation when you transition into your permanent placement. And then, just a general interview tip for those of you that are currently prepping for interviews, I would say for the presentation round to do as much research and preparation on whatever topic it is you've selected. And then for the individual and group interviews, I know that we tend to have a list of expected questions. And I can tell you that I didn't get any of the questions that I prepared for. So it's important to let your personality shine through and be your most confident self when answering these questions. And lastly, I just want to add that it's never too late to transition between fields, whether you're running reactions in a lab or you're building machine learning models. Just be passionate and curious about whatever you're doing, and you'll always excel at it. And then to close off, for those of you who joined, I'm already so proud of you. Thank you so much for spending your free period with us. My details are on the invite. So if anyone needs any advice or has any questions, you're welcome to contact me. So yeah, that's it from me. All the best, everyone, and I'm hoping to see some of you joining us soon. Back to you, Prof.
Thank you very much, Pooja, for that talk. I think some who maybe have been hesitating on what to do in the future, your experience will help them to be bold enough to venture into other fields that they may not have been thinking of earlier. Now we're moving on to our question and answer session. So the way we're going to be running it is you have to raise your hand if you've got a question, and then you will be unmuted so that you can pose your question. Sneh, I don't know whether you will be the one who will be unmuting the students, just on the alert. I see there are some questions which were being sent into the chat room, and I see Mabu had been busy answering them. I don't think there's any need for us to revisit them, but if Mabu thinks amongst the questions you've seen, there are some you may need to reiterate, we will give you the floor to do so. So the floor is open for question and answer. Yeah, you can raise your hands, then you'll be given the floor to ask a question. I'm not seeing any hands yet. Guys, let's ask the question. This is the opportunity that has come to you. Please, let's make good use of it. Okay, while some are thinking of their questions, Mabu, is there, on the questions you're responding to on the chat room, is there any question that you think it may be of benefit that you may expand on it?
It was actually quite a good question, because I think basically the question, I'll reiterate, but it was how do we like harmonize the heterogeneous data sources, which is, yeah, one of the most difficult thing when you are basically trying to build analytics platforms for machine learning or for other things, is the idea that if you have a data source 1 up to K, and all of them are different technology. So, because you'll have typically we have a SAS cluster. So SAS is a different language altogether. But then you also have what we call the reservoir, which is a giant SQL cluster, and that's SQL now. And then you have Teradata, that's also SQL-like. Then how do you get those into Spark? I think it's the thing, but it's painful, but that's what we do. So basically, we will use different connectors. So Spark natively supports connectors to different data sources, and then we'll you can imagine having data frame 1 in Spark that reads a SQL table, data frame 2 that reads a SAS table, and then joining those things to have one Spark data frame, and then doing some aggregations and other things so that you can reduce the volume of data and stuff. So typically that's what we would be doing. Even when we're building features from different data sources, we just use connectors to ensure that we can have one central place which is in Spark. So we always want to work in Spark because Spark it's very effective in terms of speed and other things.
Thank you, Mabu. Any follow-ups to the answer that Mabu has given? Okay, Venessa, I think there is one question which has come to. I see you've responded to it, but maybe for the benefit of everyone in the room, you may attend to it. I think the question was the application close at 30 June, and when it does, when does the program start, and does it start this year or next year? Over to you, Venessa.
Thanks, Prof. So all the applications close on the 30th of June, and the programs across the different segments that we have at Standard Bank will commence on the 1st of Feb. So, and we kick it off with a very, it's high impact. It's a global induction. We have all our graduates from around Africa attend what we call the Future Movers Summit. And from there, you have a further South African induction. We put you off on some soft skills, and then we transition you into business for your various programs. Thanks.
Thank you. And another one has come. I think it will be for Venessa as well. The question is, are there any winter school programs for data science that Standard Bank does offer? I think they are thinking of the June holidays. If some of them
we would if we could in terms of VAC work, but we don't host VAC work, and that's why what I would urge you to do is look at the virtual internships. So we're not hosting any particular data science program for the various universities in person over the VAC, but go and look at the virtual internships. And I think you're going to get a very good view of a day in the life of a data scientist, a data engineer, etc., etc. So that's the alternative that we offer. Thanks.
There's another one in the chat room. Is what is the recruitment process? What is the recruitment process from writing? They just want to know whether it starts from writing psychometric tests, or you start at another level because you'll be saying these guys have got degrees already.
It is no. Your degrees are a ticket to the game in terms of application. But what we have done is, I think I mentioned that stat of 38,000 applications a year. So there is an initial assessment right at the beginning, and we get high volume. So you would need to firstly submit your application, and then you would complete the first round of assessments. Thereafter, we look at your academic transcripts, your applications, and we do a shortlisting for first round interview. Post the first round interview, if you're successful, you then go and do a further battery of assessments. Once you complete those assessments, we have what you call an assessment center. And at the assessment center, you do a presentation, an interview, a group activity, and we sit and then conclude the process, in terms of who we're selecting for the following year. So that's in a nutshell. Thanks, Prof.
Okay, thank you very much. I think there are more and more coming. So I'll post the two that are here. The first one is, are there any bursaries that you do have for data science students? And the second one is, when do, I think it should be the applications. I think, when do the applications for the internship open?
So thank you so much. So with regards to the bursaries, I omitted that. We do offer bursaries. We generally look at second year upwards. Our bursaries are, inclusive of all the elements that you would need, like your book allowance, your tuition, your accommodation. We also offer you medical aid. Academically, you have to be sound. I think when you apply, we look at the financial, the financial need, and we also look at merit bursaries as well. The applications would open between August and September, and then what would happen is you go through an entire process, we shortlist, and we then offer bursaries. But yes, we do offer bursaries. Sorry, Prof, the second part was the internships.
Yes, when do the internships open?
So for the let me start with the learnerships. The learnerships open intermittently throughout the year, depending on business need. So you need to keep your eyes peeled on the Early Careers website. And the virtual internships you can access at any point in time this year, and you would be able to complete that online, over a 4 to 6 hour period, self-paced. So yeah, and you would be able to use that certificate on your CV.
Thank you very much. We're almost out of time, but I just have got one question for Pooja. Maybe it will help some students. Pooja, you from chemistry, and you were getting into data sciences, which would have been a field for people in stats, maths, computer science. Didn't you meet some people along the way who were saying, what are you doing here? Do you think we'll cope with the maths and the statistics that will be here? And if they were, what did you do to make sure that you remain focused?
Sure, thank you so much, Prof. So as I mentioned, the grad program was really rigorous with the technical training. So we would go through 3 hours a day of training for the entire year. So that really strengthened my statistical abilities, and it really took me to that next level that I needed to get at. And then in terms of what was similar between, like, chemistry and the field I'm in currently. In chemistry, we focused on creating a suitable product that's beneficial in different applications. And in banking and in data science, we aim to do the same thing. So we're trying to create the most suitable products tailored to clients' needs. So both fields, I would say, decisions are then data-driven to ensure the best outcome. And my experience in chemistry equipped me with several skills like data analysis, project management, and innovation, which really was a massive help during my transition to a data scientist.
Thank you very much, Pooja. We are out of time now, and I would want to thank you, students, for joining this Tech Talk, and would want to thank the guys from Standard Bank, Mabu, Pooja, and Venessa, for taking your time to come to talk to us of the opportunities that you do have for students. I would just want to remind the students that we have another Tech Talk. It will be a Discovery Tech Talk. It is scheduled for somewhere between the first or the second week of May. So be on the lookout for the invites for those for that TED Talk. There are questions that were asked on the chat room. I think maybe Venessa, you can maybe respond to them in writing. I think the students can just remain in the meeting before we close it to just get some responses on that. Thank you very much for joining. From me, I think we are here. And enjoy the rest of your day. Thank you.
Thank you. Bye.
Thank you. Bye.
Thank you so much. Bye-bye.
Thank you. Bye.